You are walking through tall grass 100,000 years ago. The sun sets. Ahead, the dark stalks suddenly part. In 1924, anatomist Raymond Dart examined a fossil discovered in South Africa. It was the skull of an early human ancestor, a child about 3 years old. Punctured directly through its eye sockets were 2 perfectly spaced holes. That spacing matched the canine teeth of a leopard. This child was prey. For millions of years, early humans did not hunt. They were hunted. The animals tracking us had spent millions of years evolving to kill large mammals. Take the saber-toothed cat, Smilodon, 600 pounds of muscle built to ambush, driving 11-inch canines straight through the thick necks of camels and bison. Or the short-faced bear, standing 12 feet tall, this 2,000-pound hyper-carnivore ate absolutely nothing but meat, and its long legs gave it the endurance to run down prey at 40 miles per hour. Against predators like these, early humans lacked any natural physical defenses. Even if you look at a chimpanzee, our closest genetic relative, they possess sharp fangs, intense bite force, and 3 times the strength of an adult human. We had flat teeth, useless nails, and upright postures that made us highly visible from a distance. By every objective measure of biology, we were slower, weaker, and entirely outmatched. Our species should have been wiped out completely. That extreme vulnerability peaked when the sun went down. Early humans had mediocre night vision, leaving them exposed to massive nocturnal pack hunters like the cave hyena, an animal capable of crushing thick bones to extract the marrow inside. The earliest solution to this constant terror appears in places like Wonderwork Cave in South Africa. Here, deep inside sheltered rock walls, archaeologists found layers of ash and burned bone dating back 1 million years. This diagram shows the immediate mechanical defense of those early hearths. A standard campfire projects a distinct 30-foot diameter boundary of light and heat. Predators have a hardwired instinct to avoid open flames, meaning that glowing circle became an impenetrable safety zone. Because cooked meat is significantly easier to digest, our ancestors could extract more calories while using less energy to process food. This caloric surplus provided the massive energy budget required to grow and maintain larger, more complex brains. We no longer had to spend the entire night hiding in complete silence. We finally had the secure time required to communicate and invent the next phase of our survival. Even with fire, early humans still had to navigate daylight, where predators like the saber-tooth could hit 30 miles per hour in 3 seconds. Outrunning them was biologically impossible. Instead, humans evolved the ability to sweat, cooling our bodies in motion to persistently jog for hours on end. This allowed us to execute persistence hunting. A human hunter does not sprint. They track a target at a steady pace, keeping the animal moving under the hot sun until it eventually collapses from heat stroke. The intense observation required to track prey soon mapped onto our predators. We learned to read broken twigs and disturbed dirt, noting the size and freshness of tracks to memorize the territorial boundaries and hunting schedules of the apex killers around us. Through physical endurance and careful observation, early humans stopped blindly reacting to shadows in the grass. We began actively mapping the behaviors of the environment. Out in that environment, the rules of the animal kingdom were unforgiving. For any apex predator, a severe injury or the loss of teeth guarantees starvation. Yet in Dmanisi, Georgia, archaeologists uncovered a 1.8 million-year-old hominid skull. If you look at the smooth, healed bone sockets on this jaw, it shows this individual lived for years without a single tooth. Someone else in their group chewed their food for them. We see the same pattern 60,000 years ago in Shanidar Cave, Iraq. A Neanderthal with a healed broken arm, severe arthritis, and blindness in one eye was kept alive by his group well into his 40s. This profound social care created a structural advantage. While wolves hunt in packs based on instinct, human empathy forged deep communication. We could assign distinct roles, strategize, and execute complex, coordinated plans. These photographs from a German excavation site reveal the deadly culmination of that teamwork. Archaeologists uncovered finely balanced aerodynamic wooden throwing spears. A coordinated team of humans could now strike a massive predator from 30 feet away. Prioritizing the survival of the injured allowed early humans to develop the social bonds and language necessary for group hunting. We stopped operating as vulnerable individuals and began functioning as a single, lethal collective. Around 50,000 years ago, humans began migrating out of Africa in massive numbers, carrying fire, deep communal strategy, and ranged weapons into Europe, Asia, and the Americas. This map shows expanding human paths. The data reveals a direct correlation. Everywhere humans reached a new continent, large predators vanished. The short-faced bear, saber-toothed cat, and woolly mammoth see their population lines plummet to zero, exactly as the human line spikes upward. Today, the massive creatures that hunted us for millions of years exist only as fossilized bone in our museums. Biological evolution arms predators with static, hyper-specialized traits like venom or bursts of speed, but it gave humans adaptability. Where we couldn't see in the dark, we harnessed fire. When we locked claws, we sharpened wood and stone. We survived by observing our environment, engineering solutions, and teaching the next generation exactly how to build upon them. That compounding knowledge took the most vulnerable mammal on Earth and turned it into an unstoppable force no predator could ever evolve to fight.